Hi, I'm Oni, and I'm part of two IIT alumni who post daily videos on math and physics on our YouTube channel, Mathophy. Let's get started with our JEE problem. So today we'll be starting sums on alternating current or AC. Now this is a very important chapter for all JEE and NEET aspirants. And you can get a variety of questions, but the majority of the questions will either be from impedance calculation or transformers. So today we have done a few sums on that. Let's go ahead with them. So the first sum says that when 100 volt DC flows in a solenoid, the current is 1 ampere. When 100 volt AC flows, the current drops to 0.5 ampere. If the frequency of the AC be 50 Hz, then the impedance and inductance of the solenoid are. Now we go with the first part of the problem. The solenoid has a resistance. Our first job is to find the resistance of the solenoid. So when it is in a DC case, then we do the simple V is equal to IR, our Ohm's law. In a DC circuit, V is given by 100 volts, I is given by 1 ampere, so therefore our R comes as 100 ohms. So the resistance of the solenoid is 100 ohm. Now when this solenoid is attached in a AC circuit, then the resistance as well as its inductance comes into play. So in such a case, we know that current in an AC, let's say the IAC, is equal to VAC divided by the impedance Z. So first target is to find the impedance Z. Now IAC is given in the sum as 0.5 ampere. We put the value in 0.5. VAC is given as the same 100 volts. And we need to find the impedance Z. Therefore, we can determine that Z is equal to 200 ohms. Just calculating from here. Let's put the units as anywhere. So Z is equal to 200 ampere. The next thing you want to find is the inductance. Now in this Z, when there is a resistance and an inductance, then Z is equal to root over of R square plus omega L whole square. So we put the value of Z in, that is 200 is equal to root over of R value is 100 as we have already found out. So 100 square plus omega L whole square. We can simplify this, bring the root over to this side. So we have 4 into 10 to the power 4 squaring both sides is equal to 10 to the power 4, that is 100 square, plus omega L whole square. Therefore omega L whole square is equal to 3 into 10 to the power 4. Omega L is equal to root 3 into 100. L is equal to root 3 by omega. Now omega, if frequency is given, then omega is equal to 2 pi of f. So we put 2 pi f, 100 into root 3 divided by 2 pi into f, that is 50 Hz, 50. 2 and this 100 cancels out. You have root 3, that is 1.732 divided by pi, that is 3.14. This multiplied with 0.5 goes to around 1.5. So our nearest approximation is this. So our correct option remains option number 1. Let's move on to the next sum. So the second question is, in an AC circuit, the voltages across inductance, capacitance and resistances in series are 60 volt, 20 volt, 30 volt respectively. What is the applied EMF or the total EMF that you supply to it? Now a lot of students make a mistake in this, is that they treat it like a DC. If this was a DC circuit, then you add up the voltages and you get the corresponding total voltage. But in an AC circuit, that is not how you proceed. In an AC circuit, you have to do the subtraction of the inductance and the capacitance because they are in the same axis. So here again, a lot of students make the formula that V is equal to VC minus VL plus R. Once again, this is incorrect. This formula is incorrect. The correct formula to do this is V square is equal to VC minus VL whole square plus V of R square. So for this sum, we know that VC is given as 20 volt, VL is given as 60 volt and VR is given as 30 volt. So we put those in. You have 20 minus 60 whole square plus 30 square. So that is equal to 40 square plus 30 square. That is 1600 plus 900. So that gives me 2500. That is equal to V square. Therefore, V is equal to the root over of this, that is 50. So correct option is option number 3, 50 volts. Let's move ahead to the next one. The third sum is a sum for a transformer. It says that a step-down transformer operating at 2400 volt supplies a current of 80 ampere to a load in its secondary. The turn ratio is 20:1. If the efficiency of the transformer is 80%, the primary current will be. Now, first step first, we have the voltage. Let's find the secondary voltage from the primary voltage. So we know that Vp by Vs is equal to Np by Ns. We put Vp is equal to 2400 volts. Vs is what we have to find out, the voltage in the secondary. Np and Ns is given as 20:1. Now, how do we define that whether it will be 20:1 or 1:20? Because it says that it will be a step down transformer. So my number of turns of the primary has to be greater than the number of turns of the secondary. If we calculate from here, this goes with 120, so Vs comes as 120 volts. Now, since the efficiency is given as 80%, so the power when it is transferred from the primary into the secondary coil, only 80% of the power is transferred. So the full power cannot be transferred. So to calculate that, we generally know that power of the primary is equal to power of the secondary. But in this case, since it has an efficiency of 80%, so we know that 80 by 100 of the primary power is equal to the secondary power. So we put the values in 0.8, 80 by 100 gives you 0.8. Power of the primary is the voltage of the primary, that is 2400, into the current of the primary, which we have to find out, we leave that as IP, is equal to the power of the secondary, which is the voltage of the secondary, that is given as 120 volts, into the current in the secondary, which is given in the question as 80 amperes. So let's just simplify from here on out. 120 by 2400 would be giving me 20. 0.8 by 180 would be giving me 100. 20 by 100 cancelling out would be giving me 5. Therefore, my IP value will be equal to 5 amperes. So correct option is option number 1. So whenever you're doing this transformer sum, be careful of this efficiency factor and do your sums according to that. Next day, we'll be doing a few more advanced sums of alternating current which have appeared in IIT JEE or JEE Advanced. And I'll see you again in the next video. Like, comment and subscribe to our YouTube channel Mathophy for your daily dose of math and physics.